Hey guys, in this video we are going to go over page 13, Solving Equations Graphically Part 2. So go ahead and pause the video, get page 13 copied down in your table of contents, and then go ahead and flip back to page 13. Okay, let's go ahead and get started on page 13. So on page 12, we talked about how we can graph an equation to find its solution. If it intersected one time, there was one solution. If there was no intersection, if the two lines were parallel, there was no solution. And then if the lines were overlapping, that means that there was infinitely many solutions. So we're going to look at these three equations. We're going to solve them algebraically, and then we're going to solve them graphically to see what types of solutions there would be. So we're going to start using the distributive property. So 4 times 5x and 4 times 3. We get 20x plus 12. That's equal to 20x plus 12. Notice there was no parentheses to distribute on this side. So when I solve an equation that looks like this, I need to plug it into Desmos. Remember, we type in y equals the left side of the equation, 20x plus 12, and then we type in the left side of the equation, y equals 20x plus 12. Notice that our two lines are overlapping, which means there are infinitely many solutions. So for this one down here, we have infinitely many solutions. We have a line overlapping a line, meaning every point is a solution. So algebraically, let's look at this algebraically. I could subtract 12 on both sides of my equation. That would give me 20x equals 20x plus 0. And then I could subtract 20x on both sides of the equation. And that would leave me with 0 equals 0. So anytime we have a true statement, when the two numbers are in fact equal to each other, that's true. And that's how we know we have infinitely many solutions. So we see what that looks like graphically, and now we see what that looks like algebraically. So go ahead and pause the video if you need to get caught up with equation A, because now we're going to move on to equation B. So for equation B, we're going to use the distributive property to get rid of these parentheses. So 5 times 4x and 5 times 3, that gives me 20x plus 15. And that's equal to the right side of the equation, which is 20x plus 12. There were no parentheses and no like terms, so we keep that the way it is. So now we're going to solve this graphically. So I'm going to type in y equals the left side of the equation and y equals the right side of the equation. So y equals 20x plus 15 and y equals 20x plus 12. Notice that these two lines are parallel. When two lines are parallel, that means they never actually touch. And if they never actually touch, then they have no intersection point, which means there are no solutions. So for this one, we're going to circle the no solution box. And let's look at what this would look like algebraically. So again, I could move my 15 by subtracting it on both sides. And this is going back to page 9, 10, and 11 notes. Bring down my 20x. That's equal to 20x minus 3. And then I could subtract 20x on both sides of the equation to move all of my variable terms to the left side. And that gives me 0 equals negative 3. And 0 does not equal negative 3. That is false. Those are two different numbers. Whenever we have two different numbers like that, and it's false, that means there are no solutions, just like we saw graphically. We need to be able to do it algebraically to say that there are no solutions, and algebraically. Go ahead and pause the video if you need to catch up with equation B. And lastly, equation C, same thing. We're going to distribute to get rid of our parentheses. So we have negative 4 times 5x, which is negative 20x, and then negative 4 times negative 3 plus 12, and that's equal to 20x plus 12. So we could probably assume that there is going to be one solution because that's the only option that we didn't go over yet. So let's go ahead and look at that graphically. I'm going to graph y equals negative 20x plus 12. And then on the right side of the equation, I have y equals 20x plus 12. All right, let me zoom it out here. So I see that eventually my two lines do touch, and they touch right about here at 0, 12. So I have one solution, and that one solution is 0, 12. So I can draw my intersecting points like this, and then this point in the middle where they actually touch, that's our solution. So let's look at this one algebraically. So we're going to do the same step. We're going to move this 12 to the other side of the equation by subtracting it. So bring down our negative 20x equals 20x. Now, 12 minus 12 is 0, so plus 0. Now we're going to move this 20x to the other side of the equation. So we're going to subtract 20x on both sides. Negative 20x minus 20x gives me negative 40x, and that's equal to 0. And then I have negative 40 times x, so the opposite would be to divide by negative 40. So on both sides, we're going to divide by negative 40, and x will equal 0. So in Desmos, we saw that the solution was 0, 12. So we got the 0 part. We know that x is equal to 0. Now we have to solve for y. So we're going to take our equation, our 0, we're going to plug it back in. So negative 20 times 0 plus 12. So let's figure out what that is. So negative 20 times 0, that's 0. And 0 plus 12 is equal to 12. So that's how we know this value right here is 12. So we solve for x, and then we substitute that back into our original equation to solve for y. So if you need to, go ahead and pause the video and make sure you have all of the examples on page 13. You're going to want to make sure that you know how to solve them graphically, so how we can find what the graph looks like and how many solutions there are. And then you also want to know how to do it algebraically. So when we're solving it algebraically, if we get a true statement, it's infinitely many solutions. A false statement, no solutions. If we do in fact get an answer, so x is equal to 0, that means there's going to be one single solution. So go ahead and pause the video, finish up page 13, and I will give you the assignment that goes along with it. Thanks, guys.